So there are 7 factors, and we will mainly focus on the last 4 factors, right? These are very simple. So we'll don't do not waste time on these, but we'll focus more, and you will see that how many questions they advance asked in past years, right? So let us start with temperature. You know that in order to know that the reaction will move in forward direction or backward direction, we have to see that the reaction is endothermic or exothermic, because when we are writing equilibrium constant for a sparingly soluble compound, that is KSP. KSP is an equilibrium constant. Variation of equilibrium constant with temperature, ln KSP 2 upon KSP 1 is equal to delta H naught solution upon R T2 minus T1 upon T1 T2. So we know that for delta H solution positive, on increasing temperature, the value of equilibrium constant will increase, means the reaction will move in forward direction. And for exothermic reaction, it will move in backward direction. So if they are asking that what is the effect on solubility, you should know that on dissolution of a particular compound in water, it is endo or exo. So already in lab, you have done these experiment, right? That you have make a solution of a strong base. When a strong base is added to water due to formation of cation and anion and their hydration energy, it is always an exothermic process. This is also a strong base. These are a strong base. So when the strong bases are added to water, this is an exothermic process. Similarly, when HCl is added to water or sulfuric acid is added to water, these are also strong acid. When strong acid are added to water, again, it is an exothermic process. So you know in lab that dissolution of a strong base and a strong acid into water is an exothermic process. Now, dissolution of NaCl, dissolution of potassium chloride, and dissolution of sugar. These are endothermic process, because you know that in winter it is difficult to dissolve sugar and salt in a place where the temperature is very low, right? So again, these are endothermic process, and all the hydrated salt, when CuSO4.5H2O will dissolve in water, it is an endothermic process, because in order to dissolve, you know that you have to break the bonds, and there are water molecules which are attached to copper atoms directly by covalent coordinate bond, and there are water molecules which are attached by hydrogen bond. So whenever we are going to dissolve a hydrated salt, it is always an endothermic process. You should also know that boric acid, because of hydrogen bonding, is less soluble in cold water and more soluble in hot water. And in general, in ionic equilibrium NCERT, they have mentioned that in general, heat of solution of ionic salt in water is an endothermic process, right? So this is to guess it. I'm not saying that dissolution of all ionic salt into water is an endothermic, but most of the salt, if you have to guess, so the best guess will be that it should be endothermic. I'm not saying that all salt dissolved in water will be an endothermic. There are certain salts, dissolution of them is an exothermic process. So in order to answer that reaction will go in forward or backward, you should know what is the reaction, endo or exo. The second factor is common ion effect. So due to common ion effect, solubility of sparingly soluble compound is going to decrease. So this is a very simple point, right? I do not want to waste much of the time on this, right? Like for this particular question, if I want to write the reaction, I'm just writing the reaction that calcium hydroxide is sparingly soluble. How do I know? इसका KSP दे रखा है. Whenever the substance is sparingly soluble, its KSP will be given. Like when acid is weak or base is weak, the dissociation constant of weak acid and weak base is given. Similarly, the solubility product of sparingly soluble compounds will be given. So this will be the equilibrium reaction for this, right? And now they are saying that in this solution there is calcium nitrate also, and they have not mentioned KSP of calcium nitrate. If you don't know nitrates are soluble, then you can apply that concept that KSP is not given. Here KSP is given, so this is soluble. So it will be 100% dissociated into water, and it will form calcium 2 plus ion and 2 times of NO3 minus ion in aqueous state. Now this is a saturated solution, right? So here this solid will be there, and the solubility of this solid will be S. So here S and here 2 times of S, and this calcium nitrate will 100% dissociated. So calcium 2 plus produced by this will be 0.1. So 0.1 plus S, or S plus 0.1 here, and this will be 0.2. So we can say that we are not changing the temperature, so KSP is not going to change. So KSP is equal to calcium 2 plus ion in the system, which is equal to 0.1 plus solubility into OH minus ion concentration whole square, 2 times of solubility whole square. So the value of KSP is very low and there is common ion effect. So this reaction will move in backward direction. So the value of S is small, and due to common ion effect, this is going to be further small. And that's why we can take approximation and solve. We can write that KSP is equal to 0.1. We are neglecting S with respect to 0.1. 2S whole square, and we can solve these type of problems. So you already know about this, right? So another point which is important, like this type of diagram they can ask, we have a saturated solution of barium sulfate. So barium sulfate in solid state, barium 2 plus and sulfate ion is there. So this is a saturated solution. We have added this salt and this equilibrium is established. That can be seen here, because the concentration of barium 2 plus ion and sulfate ion will be equal at equilibrium. Now we are adding at equilibrium, we are disturbing the equilibrium by adding Na2SO4 at this particular time. So when we add Na2SO4, the concentration of sulfate ion is going to increase. If you increase the concentration of product, the reaction will move in backward direction. When the reaction will move in backward direction, the concentration of sulfate ion was, after adding, was S plus A. Now it will decrease by certain amount, and the concentration of barium 2 plus ion will decrease, right? Because the reaction is moving in backward, and you can see here this is equilibrium concentration. So with respect to the old equilibrium, for the new equilibrium, if you see, the concentration of sulfate ion is more and the concentration of barium 2 plus ion will be less, right? So that is the effect of addition of a chemical species having common ion on sparingly soluble compound. Saturated aqueous solution of cobalt hydroxide. This is also an example. Find the pH. I have also discussed this, but let me discuss here. It is more useful to discuss here. Find the pH of saturated aqueous solution of cobalt hydroxide. The KSP value is given. So what will say that cobalt hydroxide is a sparingly soluble compound, and at equilibrium we can write that concentration of cobalt plus 3 ion in aqueous state plus 3 times of OH minus ion in aqueous state, right? And by using that we can write that at equilibrium the solubility of this salt will be S. Here it will be 3 times of S, and we can write that KSP is equal to S into 3S whole cube. So by solving this 227 into 10 to the power minus 44, this will be solubility. This 27 into solubility to the power 3 plus 1 will be solubility to the power 4. This is 44. So from here, if I calculate what is the solubility, it is coming 10 to the power minus 11. Now this whole thing is in aqueous medium. Water is also there, and the equilibrium constant of water here is greater than the equilibrium constant of this, because KSP of this is 10 to the power minus 43. So the effect of common ion will be more on this, and the effect of common ion will be less on this. I'm discussing this on the basis of the equilibrium constant. Kw for water is 10 to the power minus 14, and KSP is 27 into 10 to the power minus 44. So common ion का effect will be more on this and less on this. So I can say that water is solvent. So due to water, the OH minus ion concentration will be OH minus ion concentration will be approximately of the order of 10 to the power minus 7, because the effect of common ion will be less on this and more on this. And here now we can say that this is a wrong answer. This is not solubility, because of common ion produced by OH by water. OH minus produced by water is this. So now we can say that the value of KSP is not going to change. That is equal to the concentration of cobalt 3 plus ion into concentration of OH minus ion, that is 10 to the power minus 7 whole cube, which is equal to 27 into 10 to the power minus 44. Now we can simplify this, and this is telling about the solubility of this cobalt hydroxide. So very common question. This is also the effect of common ion on a sparingly soluble compound. Now, this is a question asked by JEE Advanced. So, very simple question. The KSP of Ag2CrO4 is given at 298, and the solubility we have to calculate in 0.1 molar AgNO3 solution. So, let me solve this. This is simple question only. Ag2CrO4 in solid state is in equilibrium to produce 2 times of Ag plus ion plus CrO4 2 minus ion in aqueous state, and there is a soluble compound AgNO3. इसका KSP दे नहीं रखा. Nitrates are generally soluble, so this is dissolved, and we can write it will produce Ag plus ion in aqueous state plus NO3 minus ion in aqueous state. At equilibrium, you can write this solid will be there 2 times of S, and this will be 100% dissociated. Its concentration is 0.1 plus 2 times of S. Here 2S plus 0.1. And this will be 0.1. Again, you can write that the value of KSP is 1.1 into 10 to the power minus 12, which is equal to concentration of Ag plus ion 2S plus 0.1 whole square into S. And we know that the value of S will be very small. If this is not there, we can say that this solubility of this, we can write 4S cube, and we can find out that what is the order of solubility. So the order of solubility will be 0.3 cube root into 10 to the power minus 4, right? So this is very small value. So here with respect to 0.1, this is going to be neglected, right? So if we neglect and simplify, we can say that solubility is 1.1 into 10 to the power minus 10. So B option will come. So it's a very simple question, right? Let us move further. You can solve these questions, right? I do not want to waste time. These questions are there and their solutions are also there. You can go through it if you don't get the answer, right? Now, the third point is simultaneous solubility. So in case of simultaneous solubility, there is saturated solution with respect to more than two sparingly soluble compound, two or more than two sparingly soluble compound. So here we have taken a saturated solution of calcium carbonate as well as strontium carbonate. So we'll say that it is like mixture of two weak acid, right? We can write the equilibrium reactions, and we know that the solubility of this is S1, so S1 and S1, and solubility of this is S2, so S2. Here it will be S1 plus S2 because of common ion, right? And because of common ion, they can ask a question that if these are there, the solubility of both are going to decrease because of common ion effect, right? So you already know that how to solve a mixture of weak acid. So you can find out what is the concentration of carbonate ion. Once you know the concentration of carbonate ion, you can find out what is the solubility of calcium carbonate in this mixture. That is equal to concentration of calcium 2 plus ion, which is equal to KSP divided by concentration of carbonate ion. Similarly, you can find out what is the solubility of strontium carbonate. So based on this concept, let us solve few questions. A solution is saturated with respect to AgSCN and AgBr. So again, they are stoichiometric compounds. So it's very simple to solve the problem. AgSCN in solid state is in equilibrium with Ag plus ion in aqueous state and SCN minus ion in aqueous state. Then the other reaction will be AgBr in solid state is in equilibrium with Ag plus ion in aqueous state plus Br minus ion in aqueous state, and we can write that at equilibrium these two solids will be there. The solubility of this will be S1, then this is S1 and S1. Solubility of this will be S2, so here S1 plus S2 and S1 plus S2, and this is equal to S2. Now you can write KSP1 and KSP2. This is KSP1 and this will be KSP2. And if you add that, I'm writing directly, right? It is understood KSP1 plus KSP2 under root is equal to concentration of Ag plus ion, which is S1 plus S2, right? So from here you have the common sense that there is a difference in the okay, so this value is not much difference, so we can write here that this is 1.2 into 10 to the power minus 12, and this value will be 0.5 into 10 to the power minus 12. So if we simplify, we can write that this value will be 1.7 into 10 to the power minus 12, and 13 1 point, I say here this is 1.7, and they have okay, they have not given the value. We can write here this is under root 1.7 into 10 to the power minus 6 capital M. They are asking that what is the concentration of Ag plus ion, right? So Ag plus ion concentration, from here we can find out. So if you simplify this, I am thinking that C will be the answer, because these are far away apart. So C will be the answer for this, right? Uh, Moving further, because 13 into 1.3 into 1.3, इसको अगर मल्टीप्लाई करोगे तो 1.69 आएगा, नियर अबाउट 1.7 आएगा. So this is the solution. Now moving to the question, right? This is the question asked in JEE Advanced, and this is a question of simultaneous equilibrium. कई बच्चे जिस तरह से क्वेश्चन पूछा गया है उसमें कंफ्यूज हो सकते हैं. वी हैव अ सैचुरेटेड सॉल्यूशन ऑफ AgCl, so we can write that Ag plus ion in aqueous state and Cl minus ion in aqueous state, and you have added 0.1 mole of CuCl in 1 liter solution. Ksp is given. So for saturated solution with respect to CuCl, the molarity will be 10 to the power minus 3. You have added 0.1, and there is common ion effect also. So this whole salt is not going to dissolve. Some of the student will dissolve this and try to solve it. That is wrong. Whatever the solid you have added, it will form a saturated solution. So there is a saturated solution of CuCl and AgCl, where Cl minus ion जो है वो common ion effect produce कर रहा है. This is a Cu plus in aqueous state and Cl minus ion in aqueous state, right? So Cu plus in aqueous and Cl minus ion in aqueous state. Same way you can write this solid will be there, this solid will be there, solubility of this will be S1, this will be S2, and this will be S1 plus S2 and S1 plus S2. So I can directly write the concentration of Cl minus ion is equal to under root of Ksp1 plus Ksp2. Now, if you put the value of Ksp1 and Ksp2, the difference is more. 1.6 into 10 to the power minus 10 plus 1.0 into 10 to the power minus 6. So you can neglect this value. So from there you get that concentration of Cl minus is 10 to the power minus 3 molar. They are asking that what is the concentration of Ag plus ion. So in this system, the Ksp is not going to change, because Ksp only depends on temperature. So Ksp of AgCl is 1.6 into 10 to the power minus 10. That is concentration of Ag plus ion at equilibrium into concentration of Cl minus, which is equal to 10 to the power minus 3. So this is 1.6 into 10 to the power minus 7. So this is the concentration of Ag plus ion at equilibrium. They have written this, you have to find x. So the value of x is equal to 7, right? So now we have discussed three things. We have discussed temperature, we have discussed common ion effect, and we have discussed simultaneous equilibrium. So there are further questions. These are simple questions, you can go through it. Okay, so fourth factor, this is very important, effect of hydrolysis on solubility. So for effect of hydrolysis on solubility, you should have a common sense that sometime in the question they will give directly hint that you have to consider it or not. Because of this question, you do not have to be suspicious that hydrolysis can take place in any salt, right? So if indirectly or directly they are not mentioning anything about hydrolysis, you don't have to consider it, right? So be careful about that. If nothing is mentioned about hydrolysis of cation and anion of salt directly or indirectly, then we should not consider it. So before applying, you should know that you cannot apply everywhere, right? You have to be very cautious that at which place you have to apply it, at which place you don't have to apply it. So the first thing is effect of hydrolysis of anion of sparingly soluble salt, what will happen? Hydrolysis किसका होता है? Already we have discussed. Suppose I have a solution of AgCN. AgCN का solution है. So here it is a salt of strong base and weak acid, and CN minus ion जो है इसके लिए हम this is a salt, anion is coming from HCN. HCN is a weak acid. So there is hydrolysis of Cn minus. If Cn minus is going to react with water, the pH of water is going to uh, increase because of Cn minus is taking H plus ion. So HCN will form and OH minus is going to increase. Anion की hydrolysis से OH minus बनेगा, cation की hydrolysis से H plus बनेगा. So in the question there is a hint that there is a saturated solution, and they will say pH of the solution is 9, and they are not saying that in this solution you have added any buffer solution or something. They will not say. They will say there is a saturated solution of AgCN and pH of this solution is 9. So you have to think that how the pH will be 9, because they have not mentioned that there is a buffer solution in the system, right? So this is a hint, pH is 9, so that can be possible when there is hydrolysis of anion. So if nothing is mentioned about pH, we don't consider hydrolysis of Cn minus ion. If pH is given and pH is greater than 7, then we can think that pH can be greater than 7 only when we consider the hydrolysis of anion, and then we can solve the problem, right? So we have to think about that. So here also AgCN will dissociate to form Ag plus ion and Cn minus ion, and then this Cn minus ion is reacting with water. So when this Cn minus ion will react, the concentration of Cn minus will decrease. So this equilibrium will move in forward direction. So they will ask a question that due to hydrolysis, what is the effect? Due to hydrolysis of the salt, the solubility of the salt is going to increase. So due to hydrolysis, the solubility of salt will increase, right? Now there are few questions we are going to discuss. This is a very common question. pH of a saturated silver salt of monobasic acid Ha is found to be 9. So we have a saturated solution of silver salt of this acid. I can write AgA. In place of H, I am writing Ag. So this is a salt and this is a sparingly soluble salt. So there is an saturated solution. I can write Ag plus ion in aqueous state and A minus ion in aqueous state. And they are saying that pH was found to be 9. They have not mentioned that any buffer is there or not. So this is an indication because they have mentioned that acid is weak. So we have to consider the hydrolysis of A minus ion in aqueous state. A minus ion is an ion of weak acid. It can react with water to form Ha in aqueous state plus OH minus ion in aqueous state. And at equilibrium, if we'll try to write, we should write this solid is there. The solubility of this solid is S. So here S and S, and this is going to further react. So S minus X, here S minus X. This is solvent, we don't have to write. So this will be X and X. The equilibrium constant of this is KSP, and this reaction equilibrium constant hydrolysis हो रही है. So hydrolysis constant is equal to Kw upon Ka. So you know that what is equilibrium constant for this? 10 to the power minus 14 divided by 10 to the power minus 10, that is 10 to the power minus 4. KSP value of this is given. The value, okay, we have to calculate what is the KSP, right? We have to calculate that. So we can write one equation that the value of KSP is equal to the concentration of Ag plus ion and concentration of A minus ion. And the other equation from here, we can say that X square upon S minus X is equal to 10 to the power minus 4. The pH of the solution was 9. So pOH of the solution is equal to 5. So the concentration of OH minus ion in this system is 10 to the power minus 5. And here the value of X is OH minus ion concentration. So if we put this is 10 to the power minus 10, S minus X, right? This is equal to 10 to the power minus 4. So from here we can write that S minus X is equal to 10 to the power minus 6. Once we know the value of S minus X, right, we can calculate what is the value of X we already know. This is the value of OH minus ion concentration, that is X. So the value of S is equal to 10 to the power minus 5 plus 10 to the power minus 6. This can be written as 1.1 into 10 to the power minus 6, I think, because minus 5 if I want to write, then minus 5, right? This will be minus 5, because this will be 1 and this will become 0.1 into 10 to the power minus 5. So this is the value of S, right? Now they are asking KSP. Now you can put the value. KSP is equal to S is equal to 1.1 into 10 to the power minus 5. S minus X is 10 to the power minus 6. So if you simplify, you will get A option. So very common question. Most of you know about that. But this is very important, that how you will decide that hydrolysis is taking place or not. So again, I'm discussing few questions, right? I'm just writing the reaction, how to consider it, right? What is the solubility of MnS, manganese sulfide, in aqueous medium assuming hydrolysis of sulfide ions? So again, MnS is a sparingly soluble compound. KSP of this is given. So I should write here Mn2 plus ion in aqueous state and sulfide ion in aqueous state. And H2S is a dibasic weak acid. The dissociation constant Ka1 and Ka2 of H2S is given. And they are saying that we have to consider the hydrolysis. So we are writing sulfide ion in aqueous state will react with water to form HS minus ion in aqueous state plus OH minus ion concentration. And then HS minus ion can further react with water to form H2S in aqueous state plus OH minus ion in aqueous state. इसमें ऐसा हो सकता है, one question is that in this solution what is the concentration of H2S, right? So these are the reactions taking place. Now I am writing that what is the concentration of different chemical species at equilibrium. So this solid is there. So from this solid we should write here S and S. Then I should write S minus X. Before we should know that we can neglect X with respect to S or not. For that, I am calculating the value of equilibrium constant. This is given 2.5 into 10 to the power minus 10. And here the equilibrium constant, first time hydrolysis is taking place. So that is equal to Kw. यहाँ से देख सकते हो upon Ka2. So this value will be 1. So I cannot neglect X because the equilibrium constant is greater than 10 to the power minus 5. So I have to write here X, here S minus X, and here X. Then further, this X is going to react. So X minus Y. First I will calculate what is the equilibrium constant KH2, that is Kw upon. अगर आप इसको देखो तो we can write Ka1, which is equal to 10 to the power minus 7. So this is very small. So I am writing X minus Y, but I can neglect Y with respect to X on the basis of this. So this will be X. This is solvent. This is solvent. Here I will write Y, and here it will be X plus Y. X plus Y. This is X minus Y. So this is X. If I am neglecting here, I have to neglect here also. This will be X and this will be X. So these are the concentrations of different chemical species at equilibrium. Now you can see here that if they are asking that what is the concentration of H2S at equilibrium, you can solve. This X and this X will cancel out. So H2S concentration is equal to KH2, which is equal to 10 to the power minus 7. Similarly, if you want to solve this, you have to solve the quadratic equation, that 1 is equal to X square S minus X, or you can say that S minus X is equal to X square, right? And the value of KSP from here you can write KSP is equal to concentration of Mn2 plus ion. So the value of KSP is given 2.5 into 10 to the power minus 10 S into S minus X. So you can put the value here S minus X की जगह, और यहाँ से आप S की value भी लिख सकते हो, X square plus S. So you can remove this S. You can write that this 2.5 into 10 to the power minus 10 is equal to S की जगह X square plus X and S minus X की जगह X square. So you have to multiply this. This is x square. So this whole thing is x cube plus x to the power 4. And this is a very small value. So we know that x is very small, right? So we can neglect this x to the power 4 with respect to x cube. And from there we'll get the value of x. X value will be 2.5 or 2.5 into 10 to the power minus 10 cube root. Or you can write further, right? You can simplify. This data is given, so with the help of that data you can simply 0.25 अगर तुम्हें रखना है यहाँ पे तो ये 10 to the power minus 12 हो जाएगा, right? 10 to the power minus 10.25. Okay, you please solve this, right? Cube root हमें रखना है, so please solve this. So from there you will get the value of x. Once you get the value of x, you will get the value of s, and you can calculate the concentration of different chemical species. This is JEE advanced question 2018 paper 1. So this question is based on this same concept, concept of hydrolysis, right? The solubility of salt of weak acid, right? AB at pH 3. So you can see here that this is a sparingly soluble salt, and they have given the solubility is y into 10 to the power minus 3. The value of y is given that the value of solubility product is very less. This is the value of solubility product. So this salt is there. This salt will ionize to form A plus in aqueous state plus B minus ion in aqueous state. And the Ksp value of this salt is there. And the pH of the solution is given. The dissociation constant of acid is given. pH is 3. At pH 3 they are saying the solubility value is this. So you have to consider the effect of weak acid is there. So we don't have to consider hydrolysis here, because suppose if this is going to hydrolyze, the pH should be greater than 7. So we don't have to consider hydrolysis. Something is added to this system so that the pH can be of the order, pH is equal to 3, right? So let me write here the dissociation constant. The value of dissociation constant of the acid is given. The solubility of salt of weak acid at pH 3 is this value. So if we know that what is pH, pH is equal to 3. So we know the value of pOH. pOH will be 11, right? So the solubility of salt of weak acid AB at pH 3 is given. The value of Y is given that the value of solubility product and the value of ionization constant of the acid. Okay. So here I have to understand that some acid is added to that. This is the effect. ये next concept है, but ये question यहाँ पे आ गया. Effect of pH on solubility. So first you should know that this is not hydrolysis. अगर hydrolysis होती तो pH 3 नहीं होता. It should be greater than 7. But 3 है मतलब some acid is added to system. So if it is a salt of weak acid, then on adding H plus ion to the system, this reaction will move in forward direction, because B minus ion will react with H plus to form HV, right? And the equilibrium constant of this reaction is 10 to the power 8. So reaction will complete in forward direction and equilibrium will establish from backward direction. So this I can write here. This is S and S. Now suppose initial concentration of H plus is A, and this is going to be the limiting, because this is sparingly soluble, and here pH is given. Finally the H plus ion concentration is 10 to the power minus 3, means it is initially greater than 10 to the power minus 3. Some part of this is going to react. So reaction is going to complete here. S is going to completely react and equilibrium will establish from backward direction. So here you will write S minus X, S minus X, A minus S plus X, and this is X. Since the equilibrium constant is very large, so I can neglect X with respect to S. So here it will be S. Here it will be A minus S, and this will be X only. So this is the equilibrium concentration. Now you can write that pH of the solution is given. pH is 3, means this whole value is 10 to the power minus 3. So the equilibrium constant is 10 to the power 8. That can be written as S upon 10 to the power minus 3 into X. And from there, you can find out that solubility is equal to 10 to the power 5 times of X. We have to calculate this. So the value of KSP is given. The value of KSP is 2 into 10 to the power minus 10. That can be written as S into X, right? You can put the value here. S की जगह हम लिख सकते हैं, अगर हमें solubility calculate करनी है, the solubility, so I can remove this x, so s into x की जगह हम लिख सकते हैं s by 10 to the power 5. This is equal to 2 into 10 to the power minus 10. Now you can simplify this. S square is equal to 2 into 10 to the power minus 5, or I can write that this is 20 into 10 to the power minus 6. So solubility is under root 20 into 10 to the power minus 3. I have to match this power, right? That's why I have done that. So the value of y is under root 20. अब जिन लोगों को अंडर रूट 20 याद नहीं है तो अंडर रूट 10 इंटू अंडर रूट 2. अंडर रूट 10 कितने लोगों को याद है? 3.16 एंड 1.414. यू हैव टू डू दिस कैलकुलेशन, राइट? इसको सही से करना कैलकुलेशन, बिकॉज 2 डेसिमल प्लेस तक आंसर है, राइट? So if you do it properly, then you will get the answer, and the range for this answer is given. Okay. So this is effect of pH on solubility. ये क्वेश्चन बाद में आना था लेकिन पहले आ गया, कोई बात नहीं. So we are discussing effect of pH on solubility. So effect of pH on solubility: if a salt has an anion of weak acid, and if we add a strong acid, then this anion of weak acid will combine with H plus ion, and this reaction is irreversible reaction. So अभी ये भी हो सकता है कि H plus ज़्यादा है, then this bicarbonate ion can also combine with this H plus ion to form H2CO3. If we add these three reaction, I can write that the equilibrium constant of this reaction is KSPA, solubility product in presence of acid, KSPA, right? So KSPA is equal to KSP divided by Ka1 and Ka2. And if we write here logically, because if H plus is present in excess amount and this is sparingly soluble, all the soluble carbonate ion will convert it into bicarbonate ion, and all the bicarbonate ion again will convert it into carbonic acid. So in this case, we can say that whatever the carbonate ion is present, it is almost totally converted into carbonic acid, H2CO3. So if we add and write, we should write that this will be the concentration of different chemical species at equilibrium. So the addition of H3O plus will increase the solubility of salt that contains an anion of weak acid, or the solubility of sparingly soluble base will increase. Suppose ferrous hydroxide is there and we are adding H plus ion or acid to it. So because of consumption of OH minus ion, this reaction will move in forward direction. So there are many questions based on this. One by one we are going to solve. Why we are studying? Because this is effect of acid rain on marbles. This is marble, right? So you can see here Taj Mahal walls have cracked, its marble has lost the brightness. And I have seen when I was in my school 9th class, तो हम टूर गए थे, और अभी मैं कुछ साल पहले 4-5 साल पहले गया था. So definitely the brightness of Taj Mahal has been decreased. The Statue of Liberty is also affected by acid rain, right? So that's why we are studying here. So this is a question of effect of pH on solubility, right? An acidified solution of 0.05, ये भी JEE advanced का question है, 0.05 molar of Zn2 plus is saturated with respect to 0.1 molar H2S. What is the minimum molar concentration of H plus required to prevent the precipitation of ZnS, right? So हमारे पास एक solution है जिसमें Zn2 plus ion aqueous state में है, एंड Zn2 प्लस आयन का कंसंट्रेशन है 0.05. अगर मुझे प्रेसिपिटेट करना है तो आई विल पास H2S गैस. So this solution is saturated with respect to H2S. The concentration is 0.1 molar. Now this H2S will provide sulfide ion. Depending that what is the pH of the solution, the concentration of sulfide ion can vary. So suppose I am not adding something and just I want to know that this is going, if this is only saturated solution of zinc sulfide, then what is the concentration of Zn2 plus required? So for that, I can write that KSP is equal to concentration of Zn2 plus ion into concentration of sulfide ion. And from there, I can write that KSP value is 1.25 into 10 to the power minus 22. Zn2 plus ion concentration is 5 into 10 to the power minus 2. So from here, I can calculate what is the concentration of sulfide ion. तो इसको अगर हम सिंप्लीफाई करते हैं फ्रॉम हियर आई कैन राइट दैट कंसंट्रेशन ऑफ सल्फाइड आयन विल बी 25 into 10 to the power minus 22. This should be the concentration of sulfide ion in a saturated solution of zinc sulfide. Now they are saying that we have to prevent, right? We have to prevent. So what is the pH of the solution? So we have added this H2S, and in order to stop the precipitation, at least the concentration should be this. It should not be greater than this. Otherwise, precipitate is going to form. It should be less than this. It should not be greater than sulfide ion concentration should not be greater than this. We know that when we add dissociation of H2S, we can write that K1 into Ka2. I am writing directly, that is equal to concentration of H plus ion whole square, concentration of sulfide ion upon concentration of hydrogen sulfide. K1, K2 value is given, that is 10 to the power minus 21. H2S concentration is 0.1 molar. So from here I can write that H plus whole square into sulfide ion concentration, which is 25 into 10 to the power minus 22, which is equal to 10 to the power minus 22. इसको इधर multiply करें तो 10 to the power minus 22. So from here I get that H plus ion concentration is equal to 1 upon under root 25, which is 1 by 5. So the H plus ion concentration is 0.2 molar. यही पूछ रहे हैं कि कितना H प्लस होना चाहिए कि इसका प्रेसिपिटेशन ना हो. अगर सल्फाइड आयन का कंसंट्रेशन इससे ज्यादा होगा तो प्रेसिपिटेशन होगा, राइट? अगर सल्फाइड आयन का कंसंट्रेशन ज्यादा होगा तो H प्लस आयन का कंसंट्रेशन कम होगा, राइट? सो दे आर जस्ट आस्किंग दैट what is the minimum molar concentration of H plus ion to stop the precipitation. So this is the concentration, right? So from here we can see that JEE advanced में जो answer दे रखा है, you can check this answer, right? So 0.2 is given, right? Find the number of solutions in which solubility will increase on adding a strong acid. This is a objective question. So you can see here that here the anion Br minus is there, and this Br minus will be coming from HBr. We are adding a strong acid. So this is a strong acid. If we add H plus, it will combine with Br minus to form HBr. HBr is a strong acid. It will be 100% dissociated. So there is no effect on solubility on adding a strong acid to this PBr2 solution. If I take calcium fluoride, fluoride ion is coming from HF. HF is a weak acid. So if I add H plus ion here, definitely F minus ion will combine with H plus ion to form HF, right? So we can say here calcium fluoride in solid state is in equilibrium to form calcium 2 plus ion and 2 times of F minus ion. F minus will combine with H plus ion to form HF, and because of that this reaction will move in forward direction. तो इसकी solubility बढ़ेगी. Similarly, ZnS is a salt of weak acid. Sulfide ion is coming from H2S. So this equilibrium is there, Zn2 plus ion in aqueous state plus sulfide ion in aqueous state. And if we are adding H plus ion, there is effect of pH on this salt because it will combine with H plus ion to form HS minus ion. This HS minus ion will further combine to form H2S, right? So we can say here that the solubility is going to increase. This is base. Base में अगर हम acid डालेंगे तो solubility increase होगी. This will form HI. HI will be a strong acid. There is no effect. And this is again have an effect because sulfide ion is coming from dibasic weak acid. So we'll say that there are 4 salts whose solubility is going to increase on adding a strong acid. What is the molar solubility of magnesium hydroxide in a buffer solution of pH 9? So we know that the value of KSP does not depend on addition of something. It only depends on temperature. So KSP of magnesium hydroxide is Mg2 plus ion in the system and OH minus ion in the system whole square. Here the system has pH 9 means the pOH of the system is 5, means OH minus ion concentration is 10 to the power minus 5. So if we put here the value, we can write that KSP is 1.8 into 10 to the power minus 11. Magnesium 2 plus ion concentration we have to calculate. OH minus means 10 to the power minus 10. So magnesium 2 plus ion in the solution will be 0.18 capital M. So these are very simple question, right? So you can go through it, right? Same way, this is the question, right? Calculate the solubility of AgCN in a buffer solution. Already we have discussed this question. Now this is an important point. This is very important. ये JEE advance में आ सकता है इस तरह का question. So let us discuss this question. Zinc hydroxide is a amphoteric hydroxide and it is involved in the following two equilibria in aqueous solution. Zinc hydroxide is sparingly soluble, it will form Zn and 2 times of OH minus. But if NaOH, because this is amphoteric, when NaOH strong base is added to the system, this is amphoteric, so it will react with a strong base to form this complex. So we can say that whatever the zinc hydroxide is dissolved in a solution, either this zinc hydroxide is existing in the form of Zn2 plus ion, or this zinc hydroxide is existing in the form of ZnOH4 2 minus ion. They are asking that at what pH the solubility of zinc hydroxide is minimum. तो पहली चीज है कि ये जो जिंक हाइड्रोक्साइड है इसकी solubility क्या होगी, because there are two equilibria. So the net solubility of zinc hydroxide, whatever zinc hydroxide dissolved here, will exist in the form of Zn2 plus ion. Whatever zinc hydroxide dissolved here will exist in the form of ZnOH4 2 minus ion. Now we know that the solubility product of zinc hydroxide can be written as concentration of Zn2 plus ion into concentration of OH minus ion whole square. So from here I can write that the concentration of Zn2 plus is equal to Ksp divided by OH minus ion concentration whole square. And for this reaction, I can say that the equilibrium constant Kc for the reaction is given, which is equal to the concentration of this complex anion ZnOH4 2 minus ion upon concentration of OH minus ion whole square. So from here I can write that the concentration of ZnOH4 2 minus ion is equal to Kc multiplied by OH minus ion concentration whole square. So the solubility, net solubility of zinc hydroxide can be written in this form. Zn2 plus की जगह हम equilibrium constant Ksp upon OH minus ion concentration whole square लिख सकते हैं, and here we can write Kc into concentration of OH minus whole square. So this is the solubility. तो आप ये देख सकते हैं कि initially if I am going to increase the concentration of OH minus ion, because of common ion effect, this reaction will go in backward direction. And because of that, the solubility of this zinc hydroxide is going to increase. But यहाँ पे अगर देखें at certain pH, OH minus बढ़ाने के बाद ये reaction forward में जाएगी and this will increase the solubility. So this is the net solubility. If this is the function, if we want to know that how this function is going to vary, ये function किस तरह से vary करेगा. So for minima and maxima of this function, I can write that ds upon dOH minus ion concentration. I have differentiate this function with respect to OH minus ion concentration. So this is equal to minus times 2 times of Ksp divided by OH minus concentration whole cube. And this will be 2 times Kc into concentration of OH minus ion, right? For minima or maxima, you can put here, इसको 0 put कर दोगे, and from there you will get that the concentration of OH minus to the power 4, 2 times of Kc is equal to 2 times of Ksp. And if you simplify, you can write that OH minus ion concentration will be Ksp upon Kc to the power 1 by 4. And in this way, you get the value of OH minus. How do you know that it is minima or maxima? To know it is minima or maxima, you have to double differentiate this function. Del square S upon del square OH minus ion concentration. And by doing that, you will get this value. This is coming minus plus हो जाएगा 6 times of Ksp upon OH minus ion concentration to the power 4. This is positive, this is positive. So this whole thing is going to be positive. So double differentiate करने पे positive आ रहा है. It is indicating that there will be minima. So if we try to draw the graph, अगर हम solubility of zinc hydroxide versus OH minus ion concentration का graph draw करें, we know that as we increase the concentration of OH minus, pH is also going to increase, right? So this is the concentration of OH minus versus solubility graph. So since it is minima, it means that first on increasing the concentration of OH minus, the solubility is going to decrease and it will reach minima, and after that it will increase. So this will be the variation of solubility of zinc hydroxide with respect to. So now from here you can calculate, you can put the data and you'll get that what is OH minus ion concentration, and you can calculate, right? So I think the answer pH will be 10, right? So same way you can solve here, right? We have done the same thing. Now based on the same concept, you can solve few questions here. ये तो same ही question लग रहा है यहाँ पे, right? This question, at what minimum pH will 1 into 10 to the power minus 3 mole of aluminium hydroxide goes into the solution as this? तो ये question बदल गया. Now again we can say that aluminium hydroxide is amphoteric. So if aluminium hydroxide is reacted with a strong base, it will react to form this complex ion. And if suppose aluminium hydroxide is added, it will form aluminium plus 3 ion and 3 times of OH minus. I want to write the reactions here to explain you. Same type of things, aluminium hydroxide is amphoteric. So if it is, and it is also sparingly soluble. So it is participating in this type of equilibrium 3 times of OH minus ion in aqueous state. First you increase OH minus. So because of common ion effect, the solubility is going to decrease. But after a certain concentration of OH minus, if you increase OH minus ion concentration, this aluminium hydroxide will react with this OH minus ion to form this complex ion AlOH 4 times minus ion, right? ये होगा. Same way you can say here that the solubility is first going to increase and then it is going to decrease. I have told you that how mathematically we can find out, but I am just writing here. This is pH or OH minus ion concentration. If you increase OH minus ion concentration, solubility is first going to decrease. It will reach the minima and then further it is going to increase. But here the question is, they are asking that at what minimum pH will 10 to the power minus 3 moles of aluminium hydroxide goes into the solution as AlOH 4 minus, right? So here they are saying that whatever the concentration of AlOH 4 minus, that is 10 to the power minus. They have given this concentration because whatever dissolved in this form, it is converting. So they have given this concentration. So first what we'll do, we'll write solubility of aluminium hydroxide is equal to Ksp divided by concentration of OH minus whole cube, right? Because whatever aluminium hydroxide will dissolve, it will form aluminium plus 3 and this complex ion. And similarly, we can write that the equilibrium constant of this reaction is Kc into concentration of OH minus ion, because this is solid. Concentration of this upon concentration of this will be Kc. So Kc into OH minus ion concentration, right? And from here now we have to write, because the aluminium hydroxide which is dissolved in this form, right? Let me write here, this we have written aluminium plus 3 ion concentration plus concentration of AlOH 4 minus ion, right? So this is the net solubility. They have given that this S is equal to concentration of aluminium plus 3 ion plus this is 10 to the power minus 3. This is 10 to the power minus 3. This value is given. This value is 10 to the power minus 3. So they are asking that at what minimum pH will this mole goes into the solution as AlOH 4 minus. So you can use this second equilibrium constant. Kc value for this is given. the equilibrium constant of this instability constant का reverse होगा, right? So इसका उल्टा होगा, that is 10 to the power 34. So this is 10 to the power 34. So we can write that 10 to the power 34 is equal to concentration of this, which is 10 to the power minus 3 upon uh, concentration of OH minus ion, concentration of OH minus ion. And from here, we can calculate what is the concentration of OH minus ion. From here, we can write that ये 34 ही लिखा है ना, हाँ. So if I calculate, this will be 10 to the power minus 37. So from there we'll get what is POH value. देखो मैंने सही लिखा है क्या POH की वैल्यू या गलत किया है कुछ? What I have done, KSP is aluminium plus 3 into OH minus, not this. We have written instability constant is different from, okay, so I have used this data wrong. Instability formation constant is stability constant. Formation constant of this complex ion is concentration of aluminium plus 3 ion plus 4 times concentration of OH minus ion will form this complex AlOH 4 minus ion. ये है stability. Instability इसका उल्टा हो गया. AlOH 4 minus will dissociate to give aluminium plus 3 ion plus 4 times of OH minus ion. So they have given this and I have used equilibrium constant Kc, which is wrong, right? So ये data मैंने जो use किया है वो गलत किया है. So here we can see that if I write the value of instability constant means equilibrium constant of this reaction, that is concentration of this into concentration of OH minus to the power 4, that is written here. And Ksp divided by concentration of this complex ion, and Ksp value we know, that is aluminium plus 3 into OH minus whole cube. So from here aluminium plus 3 will cancel out. OH minus will left now. So this is OH minus upon this value, right? And OH minus AlOH minus concentration is given 10 to the power minus 3. We know these two data. So from there we get what is OH minus concentration. Once we get the OH minus ion concentration, we can find out what is the pH. So this is the first part. Now in the second part, at what pH will 10 to the power minus 3 moles of aluminium hydroxide goes into the solution as aluminium plus 3. So here when we are solving, we can directly use, because Ksp value I know, aluminium plus 3 concentration I know, so we can calculate what is OH minus ion concentration. So be careful about these type of questions, right? Moving to the next part, sixth part, precipitation and preferential precipitation. So first we are trying to understand that what is precipitation. So for precipitation, ionic product should be greater than solubility product. We know that this is precipitation reaction. So for this precipitation reaction, the ionic product means the concentration of Pb2 plus concentration of I minus whole square, that is ionic product, should be greater than, for precipitation this should be greater than equilibrium constant, that is Ksp, right? So that you already know that if ionic product is greater than Ksp, precipitation will take place. If ionic product is less than Ksp, precipitation will not take place. So let us take the first example. This is very simple. We are mixing two solutions and their volume is equal. When their volume is equal, just after mixing their concentration will become half. So यहाँ पे while solving we are saying that just after mixing their concentration become half. So we have a solution in which Ag plus ion is there and Cl minus ion is there. So we can calculate what is ionic product. Ionic product is Ag plus into Cl minus ion concentration, which is 10 to the power minus 2. And Ksp of AgCl is 10 to the power minus 10. So from here I can say that ionic product is greater than Ksp. Precipitation will take place. So now I am writing precipitation reaction. Ag plus plus Cl minus will form AgCl. At time t is equal to 0, the concentration of Ag plus ion is 0.1 and Cl minus is also 0.1. So they will completely react because equilibrium constant is 1 upon Ksp 10 to the power 10. So reaction will complete in forward direction and equilibrium will establish from backward direction. So here we are writing x and x. And now we can write that x square is equal to 10 to the power minus 10. and we can solve. So from here we are getting that Ag plus and Cl minus ion is 10 to the power minus 5. So in this particular example, when we are mixing, precipitation is taking place. The ions which are precipitating is 100% reacted, but it may possible that this is more and this is less, and there is a concept of limiting reagent. For that we are solving the same type of problem. Here if you see, the moles of these two are different. Here the moles are less and here the moles are more, right? So just after mixing, we are saying that the volume is like this. So volume, we can write that millimoles upon volume. Millimoles will be 50 into 0.2 upon total volume. We get just after mixing what is the Ag plus ion concentration, that is 0.2 divided by 3. Same way NaCl ion concentration, that is 0.4 divided by 3. So we first find out that ionic product is greater than solubility product or not. This is ionic product which is greater than solubility product. So we decided that precipitation will take place. Now we are writing here, this is the case. Now this is limiting reagent. So this reaction will complete in forward direction. So there is Cl minus left in the solution. Equilibrium will establish from backward direction. So 0.2 divided by 3 plus x, but the value of x is very small. So we can neglect, we can write 0.2 by 3 and this is x. And now we can write Ksp is equal to concentration of Ag plus into Cl minus and solve it. So from there we get that Ag plus ion concentration is 10 to the power minus 9 molar. And the concentration of Cl minus is 0.2 divided by 3, right? So this is the method, same method. First we decide that ionic product is greater than Ksp, then we got that okay, precipitation will take place, then we'll write and we complete the reaction in forward and equilibrium will establish from backward
Sure.
direction.
Sir, how do we know X is negligible? How can we assume in every question X is negligible?
So that is hit and trial. Now, first I will assume the reason is that because this equilibrium constant is very large, right? So the reaction will complete and backward direction में कम आएगा. The वैसे भी अगर हम देखें यहाँ पे कि हमने ये क्यों माना है, right? So first we assume it and then we check that whatever ever the assumption we have taken is correct or not. So you can check here, the value of x is 10 to the power minus 9 order and this value is 0.2 divided by 3. So this x value is very negligible. Suppose this value is coming very small, then what you are thinking can be possible, but this value is not very small, right? Whatever the initial concentration is there, इसका जो concentration पहले था उसका आधा हो गया, इसके तो order का ही है. Reaction will complete in forward and equilibrium will establish from backward, means very less amount of the reaction will go in backward direction, and that's why we are neglecting this. We can also think that when AgCl का saturated solution होगा तो Ag plus और Cl minus का concentration 10 to the power minus 5 के order का होगा. From there also we are getting कि this value तो is very large. If we have a saturated solution of AgCl only, we are not mixing it, then it is 10 to the power minus 5. Here तो common ion effect है because of Cl minus ion, so it should be less than 10 to the power minus 5. Okay.
So sorry sir, could you again explain a brief, sir? I didn't get you.
Suppose if I'm saying that we are not mixing it, if I'm saying that I have a saturated solution of AgCl, then what is the concentration of Ag plus ion and Cl minus ion? That is under root Ksp. So this is 10 to the power minus
Yes,
5
sir.
and 10 to the power minus 5.
Yes, sir.
You can see here that NaCl is present in excess amount. तो ये equilibrium तो है, इसमें common ion effect भी लग रहा है. NaCl in aqueous state will form Na plus ion and Cl minus ion.
Yes, sir.
This is, तो ये backward ही जाएगा ना, तो 10 to the power minus 5 से तो कम ही होगा.
Yes, sir. Got it, sir. Okay. Yes, sir. Thank you,
For the
sir.
following reaction, the equilibrium constant Kc is given. ये JEE Advanced 2019 का question है. So they are asking in concept of PHEA. Fe2 plus sulfide ion will form FeS. When equal volume of 0.06 molar of iron plus 2 and sulfide ion solutions are mixed, the equilibrium concentration of Fe2 plus ion is found to be this. So पहले तो हम ये देखते हैं कि हमारे पास जो solution है, equilibrium constant Kc for this is given, right? This is 1 upon Ksp. You can see that this value is 1 upon Ksp and this value is 1.6 into 10 to the power 17. This equilibrium constant is given. When equal volume of this and this is going to mix, we have a solution in which iron plus 2 is there. Its concentration is 0.06 and volume is V. We have another solution in which sulfide ion concentration is 0.2 capital M and volume is V. When you are going to mix these two solutions, just after mixing, the concentration of iron 2 plus, because volume become double, concentration of iron plus 2 will be 0.03, concentration of sulfide ion will be 0.1. What is ionic product? Ionic product will be 3 into 10 to the power minus 3, and the Ksp value is of the order of 10 to the power minus 17. So we'll say that ionic product is greater than Ksp. So precipitate will form. We decided that precipitate will form. So we should write that iron plus 2 in aqueous state plus sulfide ion in aqueous state will form FeS in solid state. Initially, the concentration of iron plus 2 ion is 0.03 and this is 0.1. And the equilibrium constant of this reaction is very large, 1.6 into 10 to the power 17. This indicates that this reaction will complete in forward direction. So this will be the limiting reagent. This is completely reacted. This will be 0.07 and this solid is going to form here. Equilibrium will establish from backward direction. So this solid will remain here 0.07 plus X and this will be X. Again, I can neglect this X with respect to 0.07, right? Because if there is a saturated solution of FeS, then the sulfide ion concentration is of the order of 10 to the power minus 8, maybe less than that also, right? But here this is 0.07, so I can neglect, I can take an assumption, I can write this is 0.07, right? The value of Ksp you can write, value of Ksp or value of equilibrium constant you can write, that is 1.6 into 10 to the power 17, which can be written as 1 upon concentration of iron plus 2, which is X, concentration of sulfide ion, that will be 0.07. So from there we can calculate what is the value of X. Value of X is equal to 10 to the power minus 17 divided by 1.6 into 0.07. इसको और हम सिंप्लीफाई करें क्योंकि दे हैव गिवन द ऑर्डर एज y into 10 to the power iron plus 2 is x. So this value is of order of 10 to the power minus 17. इसको अगर हम सिंप्लीफाई करें तो this is 100 and ये 1.6 ही है ना, 1.6 मतलब 16, ये 1000 हो जाएगा, 16 into 7 into 10 to the power minus 17. So if you simplify 1000 divided by this, whatever value is there, you will get the answer. From this, if you simplify 1000 divided by 1000 divided by 16 divided by 7. So this is coming 8.92. This value is coming 8.92 into 10 to the power 928 into 10 to the power minus 17. So the answer given by JE was 8.93. Exact answer is two decimal tak round off karo, but they have given this range, right? Got it? Okay. This is a very good question regarding precipitation. Precipitation से related जो है ये बहुत ही अच्छा question है. And I have 6 minutes, so I would like to skip this question, right? The solution is given, you can go through it. I have to discuss the last part. That is preferential precipitation. So in case of preferential precipitation, for any two type of sparingly soluble salt, precipitate will form if ionic product will be greater than solubility product. This we know. If the sparingly soluble salts are stoichiometric like AgCl, AgBr, AgI. Stoichiometric means if the salt will dissolve, it will form same number of ions and their coefficient is going to be same. Ag plus Cl minus Ag plus Br minus. So when we write the relation between Ksp and solubility, we'll get Ksp is equal to solubility square. So we'll say these are stoichiometric solids or soluble salts. So if the sparingly soluble salts are stoichiometric and the concentration of all the target ions in the solution is same, then the target ion will that target ion will precipitate first, corresponding to which the Ksp is minimum. So these ions are target ion and this is the common ion which we are adding. So Ag plus can combine with Cl minus, Br minus, I minus to form AgCl, AgBr and AgI. So if initial concentration of all these target ions are same, so corresponding to that salt for which Ag plus concentration is minimum so that it can precipitate, right? तो हम Ag plus ion का concentration कैसे लिखेंगे? Ag plus ion concentration will be concentration of common ion or target ion is equal to Ksp. So here all the target ion have same concentration. So we are saying Ag plus ion concentration is Ksp upon concentration of target ion. This is same. So depending upon the value of Ksp, जिसका Ksp सबसे छोटा होगा उसका Ag plus सबसे कम आएगा for precipitation, right? So that is the concept, but this concept will not be valid if sparingly soluble salts are stoichiometric, but the concentration of target ions are different. Then that ion will precipitate first, corresponding to which ionic product is equal to Ksp for minimum concentration of common ion. We directly cannot say on the basis of Ksp. We have to find what is the concentration and then we will decide. If the second ion starts precipitating, suppose here, depending upon Ksp value, we know that the Ksp of AgI is smallest and then Br minus and then Cl minus. So AgI is going to precipitate first. When this ion starts precipitating, after some time, this is precipitating, this will also start precipitating. So this will be the second ion and this will be the first ion. So here, if the second ion starts precipitating and the concentration of first ion remains less than or equal to 0.01% of its initial concentration, means 99.99% of the first ion has been precipitated, then we can say that these two ions can be separated by preferential precipitation. So the point is that in the same solution, I have I minus ion and I have Br minus ion, and I minus ion starts precipitating first, right? It is coming out of solution. And after some time, suppose this amount of I minus has been precipitated, and after some time, this is the amount of Br minus ion precipitated. We are saying that when the precipitation of Br minus start, and this is already 99.99% precipitate, then we can say that we can separate Br minus ion from I minus ion. So that is the thing which we should know about preferential precipitation. So in order to explain on the concept regarding this, I have taken one example which is very common. You can get everywhere the same example. In a solution, we have three ions. These are target ions. Their concentrations are equal. That is 0.1 molar, right? Solid AgNO3 is added gradually to this solution, assuming that addition of AgNO3 does not change the volume of the solution. What concentration of Ag plus will be required to start precipitation of each of the three ions? Which ion will precipitate first? What will be the concentration of the first ion when second ion starts precipitating? What will be the concentration of the first and second ion when third ion starts precipitating? So this is the value of Ksp given. So now we are using the concept, right? So we have all these three ions in the solution and slowly we are adding AgNO3, and this is solid. It is not changing the volume of the solution. Sometimes they will give the concentration also. There also we have to assume that on adding AgNO3, the solution volume is not going to change. So we have calculated that in order to precipitate, I will take 1-2 minutes more. In order to precipitate these ions, what is the concentration of Ag plus ion required? So for precipitation, at least ionic product should be equal to that. If it is slightly greater than, then precipitate will occur, right? So that's why we are putting ionic product is equal to Ksp to get the minimum concentration of Ag plus ion to precipitate these ions. So I'm putting that Ag plus from AgCl I am talking. Ag plus for precipitation of AgCl, and Cl minus ion concentration is 0.1 molar is equal to Ksp of AgCl. So precipitation of AgCl के लिए Ag plus ion का concentration क्या हो गया? Ksp divided by 0.1, which is 1.7 into 10 to the power minus 9. Similarly, for precipitation of AgBr, it is 5 into 10 to the power minus 12. And for AgI, it is 8.5 into 10 to the power minus 16. Now, this is the concentration of Ag plus for AgI, for AgBr and AgCl. We know that this is the smallest value. We are adding slowly. So this value will come first, then this value will come, and in the last, this value will come. So we can say that AgI will precipitate first, and then AgBr, and then AgCl. Now, the third part of the question, that when the second ion starts precipitating, which is the second ion? AgBr is the second ion. When AgBr is start precipitating in the system, Ag plus ion concentration is this. So again, we can write that the concentration of Ag plus in the system is this. And what is the I minus left? Because from the system, you can see here that Ksp is not going to change. If you increase Ag plus ion concentration in the system, the concentration of I minus ion should decrease. So by time, as we are increasing this, this is decreasing. So when this is going to be equal to 5 into 10 to the power minus 12, what is the concentration of I minus left in the system? Which is equal to Ksp divided by concentration of Ag plus at that time, which is 1.7 into 10 to the power minus 5. Initially, it was 0.1 molar. Now it is decreased to 1.7 into 10 to the power minus 5. If they are asking that what is the percentage of I minus ion left, we should write that 1.7 into 10 to the power minus 5. This is the left. This is the initial amount, 0.1 into 100. So from here, if we simplify, this value will be 1.7 into 10 to the power minus 2. So this will be 0.017. So we'll say we cannot do preferential precipitation, because if it is 0.01 left, agar ye 0.01 left hota, then we'll say we can separate them, but it is greater, so we'll say we cannot separate them, right? Fourth point, when the third ion starts precipitating, when AgCl Cl minus ion starts precipitating, the concentration of Ag plus ion in the system is this. Now we can say that what is the amount of I minus left, because I minus into Ag plus is equal to Ksp of AgI. So now if I put again, it will decrease to 5 into 10 to the power minus 8. Initially it was 0.1, then it was decreased when to 1.7 into 10 to the power minus 5, and now it is 5 into 10 to the power minus 8. Similarly, we can find out what is Br minus left. So concentration of Br minus into concentration of Ag plus is equal to Ksp of AgBr. So from there we got that initially it was 0.1 and now it is 4 into 10 to the power minus 4. Right. So in this way we will solve. I have given few more examples. You can go through it. Right. Complex formation to rahi gaya. Okay. We'll discuss complex formation in the next class. Right, we'll discuss, or you can go through it. If you have problem, you can discuss, right? This complex formation is also very important. Please go through it.